Alrighty, so today I'm going to talk about modules 5, 6, and 7, which is a lot of biology, and that's not my area of expertise, but I'm going to try to get this in a way that you can understand it in terms of how general psychology works for this class purposes. So, these are a lot of basic things that you probably at least heard of in your high school biology class. Things like what a neuron is. A neuron is simply a nerve cell that's the building block of your entire nervous system. There are about 10 trillion of them in our brains throughout our brains, and they do a lot of different stuff. I do also want you to know the basic parts of a neuron: dendrite, axon, myelin sheath, synapse, synaptic gap. All of these things are very clearly shown in your textbook on around page 54. I have an old copy of the book here at home, so I'm not exactly sure what page it is, but it should be around page 54. There are sensory neurons, motor neurons, interneurons. Sensory neurons are for your senses. Motor neurons are for your motor skills, your muscular movement and such, and interneurons go in between those. So, fairly straightforward there. How neurons communicate with each other are through electrical signals. Yeah, we have electricity in our brains for real. Through chemical messengers called neurotransmitters, and through hormones. So there are all sorts of things that impact how our neuronal impulses travel through our brains, but neurotransmitters are a huge part of that. And these are little chemical messengers that either activate or deactivate a neuron in its activities. So that's basically very primitive way of describing how neurotransmitters work. Also, just so you know, the Crash Course Psychology number 3 really goes into some good detail on all of this stuff and has some great little cartoons that should probably help you be able to keep all this stuff straight if you're not familiar with it already. If you're a biology major, you probably already know all of this, but otherwise, probably haven't heard of some of this stuff at least. Some of the big neurotransmitters, as far as just overall psychological functioning, are acetylcholine, serotonin, dopamine, endorphins. Acetylcholine, I mean, endorphins are a little different from other neurotransmitters. We make them in response to certain things that happen to us, but acetylcholine is a neurotransmitter that helps enable memory and learning, and it also can cause muscular contraction, which again just helps with movement. Uh, shortages of acetylcholine in someone can cause, rigidity, can cause difficulties in getting muscles to contract in the first place, can just cause you not be able to move normally. Also, huge part of being able to form memories, being able to learn. So, acetylcholine, pretty important. Serotonin is another one that's really important when you're talking about psychological functioning, because the main class of medication that we use for people who experience depression is manipulating serotonin. These drugs called the SSRIs, or selective serotonin reuptake inhibitors, are medications like Prozac, Paxil, um, Zoloft. These are drugs that manipulate the amount of serotonin you have in your system. And it doesn't add serotonin to your system, it just prevents the reuptake of that serotonin from its sending neuron. So if you have a shortage of serotonin already in your brain, then the SSRIs are not necessarily going to do that much good, but it can help it circulate longer. And this is the main drug that we use to treat people with depressive symptoms. And it works very well they work very well for some people. They don't work all that well for others. Depression's a hard thing to treat anyway, but serotonin is one of the mood regulating neurotransmitters that is manipulated by psychopharmacology, which is just a fancy way of saying drugs that influence our psychological functioning, that impact our mood or our thinking or ways we feel. Dopamine is another very important neurotransmitter. It also influences movement along with acetylcholine, but it also um, can have some really interesting, yeah, well, interesting, some very marked psychological impacts. If you have too much dopamine in your system, you'll have symptoms of schizophrenia, which is a very severe psychological disorder that involves hallucinations and delusional thinking and just a split from reality. If you don't have enough dopamine in your system, you will have Parkinson's disease type symptoms where you have tremors, where you can't control your body movement. So dopamine is also important as far as the body movement, as with acetylcholine, but it also, as with acetylcholine, has a lot of influence on learning, your attention, ability to pay attention, your emotional state. So dopamine is what they call a feel-good neurotransmitter. It's one of the ones that gets released um, when we're engaged in pleasurable activities, that things that we enjoy, we will have some dopamine release. Endorphins are endogenous morphines, which is basically a way of saying self-made morphines. And morphines, if you're not familiar with them, are pain-killing drugs, and our bodies produce endorphins in response to pain. They also produce endorphins in response to vigorous exercise or sexual activity, well, at least good sexual activity. And these endorphins are very powerful. These are the reason that you hear about people who have gotten severely injured, like on a hike out in the woods somewhere in a national park on their own. You shouldn't do that by yourself, by the way. But how they can, fall down a cliff, break both legs, and manage to crawl, drag themselves by their arms, several miles to get help because endorphins kick in and they act as really powerful painkillers. Now, there's a limit to how much they can do, of course. They will run out after a time, but these are very powerful things that can help people when they're injured be able to, stay conscious long enough to get help and things of that nature. This is also where you get that so-called runner's high or exercise high that people experience when they're engaging in vigorous exercise, and it can be kind of addicting. There are people who do a lot of regular vigorous exercise and they feel really lousy when they don't. If they have a day where they're unable to engage in their exercise routine, they feel lousy because they're not getting that big old hit of endorphins in their system. So there are things that definitely can influence your overall behavior that, are self-made things. These are things that we produce in our own bodies. Now, your nervous system, just in general, is made up of your brain and spinal cord and all the peripheral nerves. So your central nervous system is just your brain and your spinal cord. Again, diagram around page 60 in your textbook. You can also Google it, for heaven's sakes. I mean, you guys have grown up with the internet. You know how to, I'm presuming you know how to Google things. So there's all kinds of diagrams you can find. But in the book, it's around page 60. Central nervous system simply made up of your brain and your spinal cord. Your peripheral nervous system are the sensory and motor neurons that connect your central nervous system to the rest of your body. The peripheral nervous system are all the nerves that run from your spine to the rest of your body that enable you to be able to do things. Your peripheral nervous system is split up into two different systems. You've got the somatic nervous system, which controls your skeletal muscles for voluntary movement. And your autonomic nervous system is in charge of the automatic functions of your body that keep you alive. Things like your heartbeat, your blood pressure, your digestion, things that happen even if you're unconscious are part of your autonomic nervous system. Now, within your autonomic nervous system, you have the parasympathetic and sympathetic nervous system. Now, the parasympathetic nervous system is the part of your autonomic nervous system that causes you to relax. It lowers your heart rate, it lowers your blood pressure, it lowers your respiration rate, how fast you're breathing, and gets you ready to go to sleep and calms you. So, very important part for overall psychological functioning. The sympathetic nervous system is on the other side of that coin. It raises your blood pressure, your heart rate, it gets you ready to wake up in the morning and tackle your day. It arouses your central nervous system to get up and get ready to go. And by arousal, I'm not talking about sexual arousal specifically, although that is part of the sympathetic nervous system. But these are very important things when you're talking about like people who experience anxiety or panic in particular, panic attacks. These are part of your autonomic nervous system being usually hypersensitive to things in the environment that are not actual threats, especially when we're talking about panic disorder. The autonomic nervous system is not something that's very easy to control, except for one part of it. You can somewhat control your breathing, and that has a lot to do with how calm we feel. Deep breathing exercises are very powerful tools for people who experience anxiety. It's amazing how much money I got paid, y'all, seriously, tens of thousands of dollars over the years that I was working, well, and still working as a therapist, because people forget how to breathe as soon as they get nervous, and they start having very shallow breaths, and they're breathing too quickly. And it is amazing how much relaxation you can get from your parasympathetic nervous system by simply paying attention to your breathing and slowing it down and taking a long, slow, deep breath in and a long, slow, deep breath out, and doing that for at least 5 to 10 breaths in a row. We're talking something that takes literally just a few minutes. And yet it can make this huge difference because it'll kick in your parasympathetic nervous system. When your breathing slows down, your heart rate slows down, your blood pressure lowers, and you feel more relaxed. Now, does that mean you can use breathing exercises to get rid of all your anxiety? Oh, hell no, of course not. If that were the case, nobody would have any anxiety. All you'd have to do is just, breathe. Yeah, it's not that simple. Can you take it down a couple of notches real easily in a matter of minutes? Yeah, you can. It takes some practice. There are some wonderful little apps. In fact, I have one on my phone I was going to show you. There are some great little free apps online. Let's see. I've got one. Is this one the one that I'm trying to remember which one? Has these really neat little just breathing exercises. Okay, so let me just show you what this is. You can see that? It's literally just showing you how to take a breath. Simple as that. So it's 3 minutes to help you learn the timing on taking these breaths. So things like that all over the place. Again, I got paid to do stuff like that in sessions with people before these apps were, so common. But I have recommended things like that to so many clients of mine, and they are really helpful. And again, these are things that you can download off the App Store for free. So those are really good things to have available to you if you are a person who experiences anxiety frequently. So that is a big part of, how a lot of people experience a very common psychological disorder. So that is something worth noting for this. The endocrine system is the hormonal system of your body, where you've got one type of tissue that secretes a hormone to communicate with another type of tissue in your body. Our hormones are a very important part of how we, function. And the glandular system in our body is in charge of a lot of stuff from the time we're born. The pituitary gland is what tells us how to grow, when to grow, how much to grow. And problems with that can cause a condition called gigantism, where you never stop growing. Or it can cause, growth deficits. It can cause people to have, not abnormal growth where they don't grow. So the pituitary gland is quite important. And the pituitary gland also it has hormones in it that it secretes that influence other glands. So it is actually called the master gland, which is kind of a weird thing. But the pituitary is a pretty powerful one. Adrenal gland is, of course, one you've probably heard of. If you've heard of adrenaline, yeah, you've probably heard of adrenaline, adrenaline junkies, adrenaline rush, all of those things. Well, that goes from the adrenal gland. The adrenal gland secretes, well, adrenaline and noradrenaline, epinephrine and norepinephrine. Like if you've ever known of someone who has like a serious allergy or something where they have like an EpiPen, that's an epinephrine pen of epinephrine drug to, you know, jam into your leg so you don't go into anaphylaxis when you are exposed to something that you're terribly, terribly allergic to. My husband has some pretty significant allergies, so he has an EpiPen. These are things that can really impact your overall functioning. Of course, you have sex hormones that affect all sorts of things when puberty starts, when you know, your sexual reproductiveness begins, and the sex hormones that we secrete throughout our reproductive lives have a lot of influence. Oh, for some people, a lot of influence on their behavior and their feelings. So also very important part of our overall functioning. So a lot of different things going along with that there. As far as our neural and hormone systems, also you have a brain. Y'all probably knew that. So within your brain there are a lot of different things going on there. Just again, just hitting the high spots here because I am not a neuroscientist. If you are super interested in these things, you might want to take a class at some point in your college career with Dr. Ahmed, because he is a literal neuroscientist and he knows this stuff down to such detail. It is kind of amazing. He actually used to work for the National Institute of Mental Health up in somewhere around Washington, D.C., Bethesda, somewhere. No, I think maybe Virginia. But he used to work in the field, actually, of doing these kinds of, research projects with the brain. So a lesion is simply tissue destruction. So that's not just for brain stuff, but when we're talking about brains, a lesion can be really, really problematic. Lesions are things that cause brain damage. Now, you can lesion a brain on purpose for a good reason, like to remove a growth or a tumor. You can use a lesioning procedure. There is a part of the brain that's showing some very interesting promise as far as using a lesion to eliminate obsessive compulsive disorder. There's a little part of the brain called the anterior cingulate gyrus. Yeah, I think that's right. Again, not a neuroscientist, but a very small amount of tissue, like 1 or 2 cubic centimeters of tissue. So we're talking about, I'm trying to say about yay big, little tiny, like, the size of an English pea or two. And lesioning that little area of the brain will eliminate obsessive compulsive disorder in people. Now, it is not a go-to procedure, because anytime that you are lesioning part of someone's brain, you are doing something very invasive and you are doing damage to their brain. Other than, like, to get to the anterior cingulate gyrus, they also have to lesion other parts of the brain, even if you're just using a very small electrode to go in there and just literally just zap that tissue to death. Basically is what you're doing. You're still causing some additional damage through the brain. Plus, you do have to drill a hole in someone's head, so that's kind of meaningful, because your skull doesn't heal up just as easily as like your skin does, so that can also be an issue. Ways that we look inside of people's heads, to look in their brains, to look at their brains to make sure that they're normal. We've got a number of different things at our disposal that are non-invasive, meaning that we don't have to cut someone's head open and crack their skull open to look. We've got electroencephalograms, which are EEGs. We've got positron emission tomography, which is called a PET scan. MRIs, most of you are probably familiar with that. I'm sure many of you have even had an MRI. And then we have fMRIs, which are functional MRIs. An electroencephalogram uses a bunch of electrodes that are attached to your head. It looks like a little cute swim cap with wires or wireless. Uh, bunch of little nodes on it, and it records electrical activity down to possibly even a single neuron. And again, we have trillions of them in our brains, so that's very impressive. A positron emission tomography scan tracks the use of glucose in the brain to show where there is activity, because our brains basically run on sugar. This is also why people who go on really, really low carb diets can get brain fog, because they literally need to have at least a little bit of sugar. Now, I am not saying we need the amounts of sugar that most of us consume on a daily basis, but you do need to have some sugar in your system in order for your brain to work normally, some carbs. The positron emission tomography gives you these pictures of where activity is happening in the brain. An MRI is, of course, using radio waves and magnetic fields to get a picture of anatomy of not just the brain, but the entire body. And a functional MRI is giving that very clear picture of the anatomy, but it's also showing activity. So a functional MRI is basically giving us all of the benefit of an MRI plus the information that we would get from a PET scan and an EEG. So that's pretty awesome, but fMRI machines are not nearly as common as MRIs because they're really, really expensive. All right, some basic anatomy. Again, I would highly recommend you look in the book because it's got some nice diagrams. Normally, what's normal? Normally in class, I have this lovely plastic brain in my office, and I split it up and I pass half of it around. Yeah, it's got two hemispheres that come apart. So you got a right and a left hemisphere of your brain, and they're kind of, basically the same but mirrored. And I pass one half around for people to look at in class, and I hold one up and look at and talk about it. But of course, I'm at home. I don't have my brain here with me at home. But if you look at a diagram in the book or Google it or whatever, you'll be able to see all these different parts. But just want you to have some very basic familiarity with the different parts of the brain. The brainstem is at the very top of the spinal cord, bottom of the brain. It includes your medulla, the reticular formation, and the thalamus. The medulla controls your heartbeat and breathing. So again, part of that autonomic nervous system. So that's pretty important. Heartbeat and breathing. Yeah, you die if you have severe, significant damage to your medulla. The reticular formation is a neural network in your brainstem that controls your sleep-wake cycle. So if there's damage to it because like a tumor or something, you are possibly going to fall into a coma that you never wake up from, or on the other side of that, not be able to sleep, in which case you will be dead in a matter of weeks. So that's pretty important too. The thalamus is on the top of your brainstem, and it acts as kind of a sensory switchboard from your peripheral nervous system and your somatic nervous system. So it is helping to process all of that incoming information from the rest of your body. So again, a lot of stuff going on there. Your cerebellum is at the back of the brain. It kind of looks like an additional little brain, and that's actually the word cerebellum means little brain, but it looks like a brain, except it's separate. It's another brain that's stuck at the back of your head, and the cerebellum processes a lot of sensory input, your voluntary movement, your sense of balance, a lot of things having to do with your ability to move around normally is processed through your cerebellum. Within the limbic system, actually I should have made these go over. The limbic system is made up of the hippocampus, the amygdala, and the hypothalamus. The hippocampus is a big part of the learning and memory formation. If you have damage to the hippocampus, it is very likely you're going to have some kind of amnesia. I'll talk about amnesia later in the class, but you have two types of amnesia. You have anterograde and retrograde. Anterograde means you can't form new memories, and retrograde means you can't remember things. So you can have either of those or both in some cases with damage to the hippocampus. There's Also, the amygdala, which is a large part of your fear and rage responses. So, a lot of your anger and fear go through your amygdala. And this, again, your limbic system, I didn't actually describe where it is. It's kind of in the middle of your brain. It's this kind of donut shaped structure in the center of your brain. And it's I mean, they make jokes about it almost, but it's your lizard brain. It's kind of the dumbest part of you. Especially as far as the amygdala goes, fear and rage, neither one of those things are really optimal states for us to be in and be able to engage our higher order thinking skills. We are not able to think critically, we are not able to think clearly when we are extremely angry or extremely scared. Our smarts kind of go out the window, they go offline when the amygdala is in charge. And unfortunately, there are a lot of things out there, a lot of entities, a lot of media sources that do a really good job of manipulating people's amygdalas and do a really good job of manipulating our limbic system and keep people, upset, scared, angry. And when you're scared, when you're mad, you don't think clearly. That's why we do a lot of stupid stuff when we're mad. That's why we say a lot of awful things when we're angry with other people, things that you can't take back that can ruin relationships. So just something to, just be aware of. It's this little tiny structure in the center of your brain that can really be a powerful force for bad in your life. I mean, how many people have you known, in your life that had anger issues? If you have to go to anger management, things like that, you can get into an awful lot of trouble. There are lots and lots and lots and lots of people who are spending big chunks of their life in jail because they couldn't control their amygdala responses. So, things for people to just kind of be aware of. Your hypothalamus helps govern your endocrine system. So that's a pretty important job. And what they jokingly call, I think in the book, I mean, I heard this back when I was an undergraduate taking Gen Psych way back many, many decades ago. But it talks about the 4 F's, which are feeding, eating, fighting, fleeing, so fight or flight response, and sex. So yeah, haha, that's a joke. Yeah, but those 4 things, those are pretty powerful and also fairly primitive forces that really have a lot to do with our behavior for a significant chunk of our lives, that we spend time either looking for food or eating, looking for sex or having sex, or the fight or flight kind of thing. There's a lot of psychological energy that gets taken up with those things, so that's also a potential thing there. Module 7, the cerebral cortex and our divided brain. The cerebral cortex is the outer covering of your brain. It's the wrinkled part. If you've ever seen a brain in real life, a human brain has a lot of what are called convolutions, and convolutions is simply a fancy way of saying wrinkles, but these creases in our brain. The cerebral cortex of any particular organism, the wrinkles indicate sophistication of thought. The cerebral cortex is an indicator of basically how intelligent a species is. Now, of course, individual differences are there in all species. And there are animals that really have little more than a brainstem. Fish, there are lots of fish who really don't have anything but a brainstem. Chickens. Chickens are dumb. Chickens barely have any kind of a cortex. They barely have a brain. They basically have a brainstem. So again, they're good eats. They're dumb. They're easy to catch. Well, they're not as easy to catch as you might think, but they're not sophisticated animals, and that's part of why they're fairly low on the food chain. The cerebral cortex in humans is very, very large compared to a lot of other animals in the world. And the cerebral cortex is very wrinkled. It has lots of convolutions compared to most other animals. I believe there's a really good illustration in the book as far as how large the cerebral cortex of a brain of different animals is spread out compared to a human. Like on a mouse, it's like the size of a postage stamp. On a chimpanzee, it's fairly large. Human, larger still. Lobes of the brain. So these are basically sections of the brain that basically have different jobs. So different parts of the cerebral cortex. The parietal, let me go in order. The frontal lobe is at the front. Yeah, it's at the front. The frontal lobe is just right here behind your forehead. For once, there's a name of something that makes some sense and is easy to remember. This is the center of your higher order thinking, your impulse control, your judgment, your planning, a lot of your ability to produce speech as far as coming up with words to say are centered in your frontal lobe. Your parietal lobe runs basically over the top of your head, between your ears, kind of this top section of your head. And the parietal lobe is largely in charge of sensory input for your sense of touch and body positioning, which basically means your coordination, your ability to navigate through the world. So a lot of your just general movement, how graceful you are or how clumsy you are has to do with your parietal lobe. Your occipital lobe is at the very back of your head, and your occipital lobe processes visual information, and it goes opposite. Now, again, you have two lobes. You have two hemispheres of your brain. You have a right hemisphere and a left hemisphere. And for your occipital and temporal lobes, your left occipital lobe processes the right eye's information. The right occipital lobe processes your left eye information. Temporal lobe, same thing. I don't know why. That's just how it works. The temporal lobe is above the ears, and again, something fairly easy. Think of tempo for music, sounds. It processes auditory input, so processes sound, processes also your sense of smell. So your sense of smell actually gets processed in a part of your brain that's above your ears. Go figure. So there's all of that going on with the lobes of your brain. So that's something that you should remember, make it a lot easier for the exam. Phineas Gage, again, not very many names, but he's a notable person in psychology, not because he was a psychologist or did anything in psychology personally. He was a case study. Remember me talking about case studies early last week? He is a very unique case study. Phineas Gage was working as a railroad worker in 1848, and he was in the wrong place at the wrong time, and they used a lot of dynamite to blow stuff up back then to set the railroad system through the country. And he was injured by a pipe that blew up, and it entered his head somewhere around I don't remember which eye, but it entered in his forehead and exited out through the top of his head. Now, someone having an injury like that back then wasn't that unusual, but the thing that was unusual was that Phineas Gage survived, number one, and that he survived relatively intact. In 1848, doctors weren't even routinely washing their hands between patients. People died of infections and dysentery and all kinds of nasty, just infections, just as often as they died from disease and injury, because infection would set in and kill people. What is unique about Phineas Gage's injury was that it was an explosion. Explosions produce a tremendous amount of both velocity and heat in the things that are, exploded. So this pipe, by all reports, was going at a very high rate of speed, and it was also extremely hot. So the idea that is gathered from all these many, many decades, years later, was that apparently the pipe that went through his head was so hot that it actually cauterized and sterilized the wound on the way through. So not only did he not bleed to death because it cauterized the wound and shut all the bleeding down, but it also sterilized the wound because of the high levels of heat. So, what's really notable are not only the weird circumstances that just made a guy able to survive getting a big chunk of his head blown through, is that he had a complete personality change after the accident. By all reports, Phineas Gage had been a nice, jovial person before he had his accident, and afterwards, he was a very nasty piece of work. He was mean, and he got into fights, and just had a completely different personality, like a Dr. Jekyll and Mr. Hyde situation. That was fascinating to people, and he became a medical anomaly. Doctors wanted to talk to him. There were news reports all over the world about this man, and what's really notable about him is that Phineas Gage really was probably a big part of what prompted the field of neuroscience. He was kind of a catalyst for doctors and other people in the sciences to want to study the brain, because prior to Phineas Gage's situation, there was not really concrete evidence that that gray matter, that lump of tissue inside of our heads, was really the biggest part of making us who we are, as far as our behavior, our personalities, all of that kind of thing. And after Phineas Gage, that's a pretty clear indication that having a brain injury like that can completely change who you are, because it blew out a big old chunk of his frontal lobe, and it completely changed his personality. When you have someone who has a brain injury like that, yeah, it's going to change their personality. It's going to change their speech patterns. It's going to change their judgment, their planning, just everything about you as far as your personality is largely in the frontal lobe of your brain. So that's why Phineas Gage is a really notable person. One other thing, just a couple of real quick things. An aphasia is an impairment of speech. This is something that's relatively common that happens when you have some kind of traumatic brain injury, especially if you have someone who has a stroke in either the frontal or temporal lobe of the brain. Aphasias are relatively common. I'll talk about those again in class, but that's also something that can happen. Plasticity of the brain is the ability of the brain to repair itself after damage. This is something that we lose as we age. Children have much more brain plasticity than adults. Older adults have less brain plasticity than younger adults. I have a 3.5-year-old grandson. If God forbid something happened to him, like he had some kind of brain injury, brain tumor, something like that, there have been cases where a small child would have a brain tumor. They go in and scoop out a golf ball sized chunk of their brain, and they recover completely fine. Their brain reroutes around the damage and goes on and grows, and there's no significant, if any, indication that anything like that ever happened. But if something like that happened to me, I might be a head in a bed for the rest of my life. So there's a huge amount of difference in the plasticity of the brain of a younger person versus the brain of an older person. So that's something, again, notable when you're talking about someone who has a brain injury or brain damage or, a stroke or something like that. The older you are, the more damage it's typically going to do, and the worse the prognosis is going to be for that person. And finally, the corpus callosum. So I talked about there's the two hemispheres of the brain. You got the right and the left hemisphere of the brain. The corpus callosum is a band of neural fibers that connect the two hemispheres and allow them to communicate with each other. There is a thing called a split brain procedure that is done for people who have really severe epilepsy, which is a seizure, a disease where people have seizures. And in really, really severe cases of epilepsy, they will do what's called a split brain procedure, where they cut through the corpus callosum, because what's basically happening with epilepsy is someone's having a short circuit in their brain. That's oversimplifying it, of course, but it's basically electrical signals in the brain that just go haywire and cause the person to have a seizure that's so bad that it can kill them. So in those cases, you've got someone with a split corpus callosum, and the two sides of the brain aren't talking to each other anymore. So you can have some really weird effects of that. Like, remember watching a video when I was in college of someone who was in the grocery store, and one hand was taking stuff and putting it in the basket, and the other hand was taking it out and putting it back on the shelf. Things like that. So if you want to see some really interesting split brain stuff, Google it. There's some interesting videos out there for it. So there's that. Okay, so that is it for this week. For next week, we'll be moving into the next section. You've got your assignments in Canvas to do, and just make sure you get those done. And we'll see you on Tuesday. Have a good one.